tell, well, let me just write it out. Which molecule is more polar? That one's polar, right? This is not polar at all. Which one's more polarizable?
First one.
Yeah, so it's hard to compare what's got the higher boiling point, right? What's more polarizable, what's more polar. I'll try to give you things that are a more straight up comparison. What's more polarizable? Yeah. Bromine is more polarizable than chlorine. So I won't have you choose the comparison between what's stronger, dispersion forces or dipolar forces. It's hard to know sometimes. Yeah.
So if something has like more electrons, it's going to be more polarizable. And
Exactly.
if they're bound less tightly.
And they have to be bound less tightly.
So
Yeah.
like stronger intermolecular forces are going to mean the electrons are bound tighter, and it's less polarizable, or not necessarily.
Wait, just say that loudly so I get it.
Higher intermolecular forces, does that mean the electrons are bound more tightly?
No. So CBr4 has higher intermolecular forces, right? It's less volatile, or its boiling point is higher. And bromine's electrons are bound less tightly to it than chlorine, right? The electron cloud is bigger in bromine, and so it's more polarizable. Cl4 or C, if this existed, right? The electrons are held very tightly around fluorine, right? This is the least polarizable. So if I had you order these,
So more electronegative means electrons are bound tighter.
more electronegative means less polarizable, right? The electrons are bound tighter. So what's got, let's say, what has the lowest boiling point of these three compounds?
CF4.
CF4, lowest boiling point, lowest intermolecular interactions, because the F is holding on to its electrons, so this is not very polarizable. This is highly polarizable. Yeah?
So isn't that the more polarizable it is, the higher its volatility?
No. Volatility is what? If a molecule is volatile, does it want to be stuck to other molecules?
No.
No. So a volatile molecule has low intermolecular interactions, right? Is anyone confused on volatility and boiling point, what the relationship is?
The higher volatility, the higher boiling point? No. Lower boiling point.
Lower boiling point is higher volatility. Make sure you know that. Yeah,
Can you go over Coulomb's law?
sure. So first off, what does Coulomb's law describe? What's that?
Force between two ions.
Force between two ions, right? So anytime you have Coulomb's law, it's the force or the energy between two ions, right? Does it depend on distance? Yeah, force between any molecules definitely depends on distance. What else does it depend on?
Charge.
Charge, whether this is +2, -2, etc. That plays into Coulomb's law. What else plays into Coulomb's law? If I have two ions sitting in vacuum versus two ions sitting in water, dielectric constant, right? So, Coulomb's law, the force between charges is dependent on the charge of one, dependent on the charge of the second, right? You just have to know that Coulomb's laws are squared, so this is the force. And dielectric constant is in there, and it's in the denominator. Why is the dielectric constant in the denominator? Higher dielectric constant, lower force between those ions, right? So if you put sodium chloride in water, high dielectric constant, there's very low force between those ions. They drift apart. If you put sodium chloride into vacuum, that sodium and chloride are stuck together, right? There's a high force between them. What am I missing? There's some 4 pi E0. Is that it? I don't have the equation in front.
Constants besides E0, right?
What's that?
Those are just constants, so besides E naught.
All of these are constants right here. Yeah. E naught is vacuum permittivity. Dielectric constant is, the medium that ions are in. Separation. Distance. And this is charge. So there's other forms of Coulomb's law where you have Z's and E's up here. I mean, that's just changing the charge into other types of units. But as long as you know about R squared and the dielectric constant, you'll be good on Coulomb's law. Yeah?
Can you go over ion hydration in water as well?
Sure. Is everyone cool with Coulomb's law? All right. So when you put sodium chloride into water, what happens? Sodium and chloride dissolve. Why does sodium chloride dissolve in water? Water has a high dielectric constant. Sodium and chloride have a very favorable interaction with water. And so that water hydrates these ions, right? And how much water is around these ions gives us our hydrated radius, right? So you have an ionic radius. What's the radius of the ion when it's in the solid? Then you have this hydrated radius, is how much water do these ions carry with it? And so, what was the question?
Just to go over it.
Oh, just to go over it, yeah. So the essence of this problem is, sodium chloride, if it's in vacuum, or it's in cyclohexane or benzene, something that's a low dielectric constant, benzene. Hexane. Low Kd. So you have unfavorable interactions of sodium chloride with these different molecules. The sodium chloride won't dissolve. The reason that sodium chloride dissolves in water is these water molecules hydrate these ions and they allow the force between these two ions to be very low, as we know from Coulomb's law. So the ion hydration comes in where now you have water that's around these different ions, and so you have the ionic radius of the ion here, radius of the ion. Here you have hydrated radius. What does the hydrated radius depend on? Does anyone know? Does anyone remember? Yeah.
The number of layers of organized water molecules that go out from the ion.
Yeah, so the hydrated radius tells us about how many water molecules are around the ion, and that's really dependent on the charge density of the ion. So if you have a very high charge density, if that ion is very small, like lithium's very small, it carries a lot of water around it. If the ion is very big, like bromine, bromine's a big ion, its charge density is low, there's not a lot of ions that are with bromine. So it has a lower hydration number. Now that's details. I think you just need to know that hydrated radii exist, and you can answer the homework problems on hydrated radius and things like that. Any other questions on hydrated radius? Why it dissolves in high dielectric constant? It's 9:45. Any more questions? Yeah.
How many questions is the exam?
That's a good question. Did you get through all the example questions in class
Yeah.
with the sub? Yeah. And that was 9? Yeah. And you had discussion between them, right?
Actually,
Oh, you didn't. You got almost to the end, right?
Yeah, almost to the end.
So you had 9 questions. You almost got to the end, but you had time to solve the problem and then time to talk about it. So there'll probably be more than 9, and maybe if you double 9, you have about the amount of time. So it's not going to be like 80 questions, right? It's not going to be like, what were your Chem 110 exams like?
20.
a multiple choice.
20 of multiple choice in how long?
No, 28 all multiple choice.
An hour, I think it's like 85 minutes.
85 minutes, and where they write down formulas and stuff like that?
And multiple choice.
You had to do
there are math
calculations.
Concepts, some questions, yeah. So my exams will not be multiple choice. It'll be, give me your answer like on the homeworks are, but it'll be more than 9, less than 20, somewhere in about that range. You'll have to, you won't be able to spend 20 minutes on one problem, but you'll have enough time. You have, how long is class? 85 minutes? 75 minutes, so, you'll probably have 4 or 5 minutes per question to answer, something like that. Other questions? Yes?
Could you just explain to me what we need to bring in? So do we get one side of the sheet? I'm like.
Yeah. So your crud sheet can be 2 sides,
Oh, okay.
8.5 by 11. Okay, so you have 8.5 by 11 piece of paper. It has to be handwritten, and then you can bring a periodic table since we don't have one in the room. But the periodic table can only be one side, and there can't be anything on the back of the periodic table. Even if it's periodic table-like information, you can't have that on the back. So when I walk around the room, I should see one sheet with both sides, and then a periodic table with nothing on the back, both 8.5 by 11. Calculator, that's not your phone and not your iPad. A pencil. If you want to bring a ruler, that's fine, but you don't need a ruler. Just be able to draw straight lines. Yeah?
Are you allowed to write in the space around the periodic table?
No.
What about like trends on it, like periodic trends on the periodic table? Could you write that?
Why don't you put that on your crunch sheet? Yeah.
Okay, in your periodic, there's a couple that look on Google on periodic tables. There's some pretty fancy ones compared to some generic ones. Does it?
Yeah, so think about what we've discussed. What's important on the periodic table? Having the right things in the right rows, maybe electronegativities, maybe not. But you can't handwrite anything on the periodic table like the trends or something. It's not a note sheet. It's just I don't have a periodic table, so I could put it up on the board while you're taking the exam, but then everyone's looking up. It's a big hassle, so just one periodic table. I could hand out a periodic table with the exam, but you guys bring your own. You'll be comfortable. Believe me, if you know what the concepts are in the class, you won't need any note sheet at all to do the exam.